And welcome to this practice set on composition of functions, where we're going to go through executing the procedure of composition of functions. Please like and subscribe if you find this practice set helpful. Comment below with a question, some feedback, or a request, and check out the many other videos and playlists on the channel. As always, pause the video to work these problems on your own, and then come back to check your work. All right, so this is actually the second go around at recording this because the error on the table that if you watched the video lesson, which I hope you did, I actually copied that same error into, like, I edited the functions but did not edit the table, realizing that I had the typos in the table. So we have it fixed, and we're going to go for a second go around on doing these problems. So if you witnessed the debacle on that problem in the actual lesson video, hopefully we can execute it smoother this time. So for numbers 1 and 2, you're given two linear equations, f of x equals 3x plus 4 and g of x is equal to negative x minus 7. And we are asked to compose them in both directions. So f of g of x and g of f of x. And in terms of remembering how to execute the strategy, what I will tell my students is whatever function you see listed first, start by simply copying down that function. So if you see the f listed first, copy down f. If you see g listed first, copy down G. That will get you started. Do not try to, don't try to write them side by side. Don't try to multiply them. I will see students do this all the time, and it's kind of a tip off that I did not watch the video or pay attention in class. I took a nap. I went to the bathroom. I don't know. Because I'm usually pretty clear about this is a good way to start. And it comes from when I took Algebra 2 and I learned these skills myself, I would often just get the procedure backwards. Like I knew what I wanted to do and just couldn't remember the notation part. So once you have that first function down, now you're going to take the second function, whatever the second function is, and that is what is going to go in everywhere you have an X. So just kind of highlighting that. And what I'm going to do when I rewrite this is I am going to accentuate that color again. So instead of 3 times X, I am going to do 3 times G, which is negative X minus 7, and then do the plus 4. So literally what I have done there is I have taken out the X and I have replaced it with negative X minus 7. Over here on the right, I'm going to do the same thing. Now notice that negative is all by itself. It is writing solo. And the X is going to be taken out and replaced with F, which is 3X plus 4. And then we'll subtract the 7. At this point, you have technically done the composition, meaning you have replaced one function, or plugged one function into another. The rest of the process from this point on is simplification, and it can be where things tend to go wrong. But on the right left-hand side there, we are going to distribute that 3 through. So 3 times negative x is negative 3x. 3 times negative 7 is negative 21. And then combining negative 21 plus 4, okay, that will give us what? Negative 17. Over on the right, we are distributing that negative. So we'll get negative 3x minus 4. And then combining the negative 4 with the negative 7, we get negative 11. And again, notice that these are not the same. So that means that composition is not commutative. It does matter what order you do it in. So f of g of x and g of f of x do not necessarily give you the same thing. Doesn't mean they never can give you the same thing, but as an operation, they are not commutative, okay? There's special cases of all kinds of things where you might see things that are commutative only with certain numbers or in certain situations, but a future lesson will explore some of that. All right, next one. This is intended to do two things. One, we're going to change up the functions. Now, I did keep them fairly simple. So we do have a fairly simple quadratic equation and a very simple linear equation there, and the notation. So you could see the notation on the previous slide, or you can see the symbol for composition, which is that open circle. Now, that doesn't change anything about the strategy, though, which is good. So whatever that first function that you see listed is, that's where we're going to start, is copying down that first function. So for number 3, that's going to be f, which is x squared. And for number 4, that's going to be g, which is negative 3x. And as with before, we're going to take the second function and it's going to go in wherever we have an x. Okay, if you've got multiple x's, then you are going to have multiple substitutions. So here, instead of x squared, we are going to plug in g, which is negative 3x. So instead of an x squared, we're going to have a negative 3x all squared. Over here, instead of negative 3 times x, we are going to have negative 3 times whatever f is, which is x squared. Now, right here, I think this is one of those interesting spots. We might say these out loud the same way. You might hear negative 3x squared or negative 3x squared, but they are not the same because the placement of the parentheses does matter. So in the one over there on the left, you might hear someone say, instead of negative 3x squared, you might hear the words negative 3x all squared, and that all, ALL, is used to be a verbal signifier of the presence of parentheses, meaning we're going to square the negative 3 along with the x. So what we've got going on over there on the left is negative 3x times negative 3x, which will be positive 9x squared. On the right, those parentheses are not doing anything. Now, if we had something more interesting than x squared, like x squared plus 2, then they would be doing something, but we don't have anything more interesting. So that is just negative 3x squared. And there we go. So a nice little review there of the importance of the parentheses and our verbal way of saying things out loud. Okay, welcome to our revised table. So about 7 or 8 minutes into the last attempt at reviewing this, I realized my table is still jacked up. Like, you edited some of it, but not enough of it. So welcome to the edited table. We're going to use that table for 5 through 8. So we're going to do 4 of these using the table, and all of these are done piecemeal. So looking at number 5. We are going to start with what is g of negative 2. Coming over to the table, to negative 2, and then we go over here to g of negative 2, and we realize g of negative 2 is negative 1. Therefore, f of g of negative 2 really is f of negative 1, and we hop over here to the table, go to negative 1, and we find the value for that is 1. Yay. Next one. This is g of f of negative 1. Now, we just did f of negative 1. Okay, just found what that was. F of negative 1 is 1. So g of f of negative 1 is really just g of 1. So we come down here to find 1 and go over to the g, and that is 5. And next one, we have f of g of negative 1. So this is that, like, is it commutative? So g of f of negative 1 and f of g of negative 1, do they land us in the same spot? So we're going to start by doing g of negative 1 and finding what that is. So there's my negative 1. G of negative 1 is 1. And so this becomes f of 1, which is 1. Now, could in individual cases, could that end up being the same number? Yes. Okay. It's going to depend on what's in that table. Whether you have like an individual value where those numbers kind of bounce back and forth, and g of f of -1 happens to be the same thing as f of g of -1. Yes. But in general, they are not commutative. Okay. We don't want to take an exception and then generalize the wrong way from it. All right, last up, let's do 8, which is g of f of 0. So going over to our table and finding f of 0. F of 0 is 0. And so that ends up being g of 0. So we end up landing in the same line, which is 3. Okay, so that's how we would do the composition from a table. Now, what you need to show for work for that is, listen to your teacher. Okay, listen to whatever your teacher gives you for instructions on something like that. Okay, and lastly, numbers 9 and 10, use the graph below. And remember that F is blue, and I think I did remember to go type that onto the slide, and G is red. So we have F of, it's number 9, G of 1. So on the graph, we got 1. We're going to come over here to 1, and looking at the red graph, we see that that seems to go through the point 1, 1 right there. So when X is 1, Y is 1, which means that this is F of 1. And so coming over to the 1, now I'm going to go up and find F, and that appears to be a 4. So we have the point 1, 4, meaning that that is a 4. And last one, we have G of f of 1. Another like potential, is this commutative? Now we got to go find f of 1, which we just found f of 1 is 4, so we're not going to reinvent the wheel. So that becomes g of 4. So coming over here to the 4, and then we got to go find function g, which is down here. So right there, and kind of scooting back, that looks like that is at a -5. And again, as I said in the instructional video for this, the graphs are not going to be hugely common ways to do this because of the impracticality of using a graph for this particular procedure, but that doesn't mean that you can't ever see it or that you shouldn't have the fluency to be able to interpret the graphs correctly with this particular operation should the need arise to do that. So, all right, well, that is that for the review. So please don't forget to like and subscribe if you found this helpful. Engage with a comment or a question. Maybe you have a suggestion or a request for another video you'd like to see, and check out the many other resources on this channel. I'll make sure that I link below to some of the playlists. We've got all kinds of playlists. We have algebra tiles playlists and Desmos playlists, and how to answer multiple choice kind of question playlists, and all kinds of stuff that you might find helpful or interesting to appeal to your inner nerd. So thank you for watching, and I hope to see you in a future video.